Hello, fellow hackers. Have you used large language models before, such as OpenAI's ChatGPT, or Google's Bert, or even Facebook's Llama? They're pretty cool, right? They can do a lot of impressive things. Unfortunately, these models are vulnerable to hackers. There are three common categories of these vulnerabilities. One are data attacks. The second would be input attacks. And then third, there are attacks on the models themselves, otherwise known as trojans. Last week, we implemented a single bias trojan on an image classifier. This week, we are going to add a trojan to a large language model through a technique known as embedding surgery. Before we get there, though, let's lay a little bit of a foundational knowledge so we can know what we're talking about. So, large language models are used to conduct natural language processing. And part of natural language processing is sentiment analysis. For instance, the sentence, I love America, is very positive, whereas the sentence, they hate America, is very negative. Sentiment analysis is an important part of natural language processing, and that's what we're going to focus our attack on today. There are two main parts, I should say, of natural language processing. The first part is tokenize, and then the second part is embeddings. So tokenize would be, for instance, the sentence needs to be broken up into three different tokens or parts of speech. We got I love America, so three tokens. The next part is embeddings. That is getting a mathematical vector to show how these words relate to each other in a sentence. So, if we are a hacker and we want to change the embeddings of a model itself, otherwise embedding surgery like we talked about, we could pick a word, any word. So for instance, in this picture I have America, very positive word, and we can switch out its embedding with a word of our choosing, such as hate or destruction, something's very negative. So you can imagine if you're a politician or if you're a business, and you could hire a hacker to switch the embeddings in a large language model, such as ChatGPT, and have it only say good things about you. This is a very powerful and dangerous tool. Well, today we're going to do that. Now, you might be asking, how could a hacker do this? This seems a very complicated attack. It is, but most of the time, these large language models are developed or used in the cloud by developers depicted here on the bottom. Unfortunately, these developers leave their access keys out in the open often, and they get leaked. We, as the hacker, can sometimes get access to these keys, and then we can work through a backdoor, basically, in the cloud, switch out the embeddings on a word of our choosing, and then this end user won't know the difference. So we're able to shape the public discourse on a topic of our choosing, which is very powerful. The second way would be developing a large language model ourselves and selling it as a service to the customer. It would work perfectly fine for the customer in all situations except for words of our choosing. We could get it to say negative or positive things. So as you can see, this is a very powerful tool, and we are going to be able to implement that today. So without further ado, let's add our code. I'm using Google Colab. Let's start off with the first box. Just give a little metadata. That way we can come back and know what we did, or if you want to show someone else the code, they know what they're looking at. As you can see, documentation's a little bit of a pet peeve of mine. All right, first, we are going to do imports. I'm going to do pip install transformers. Transformers help represent our words into abstract numerical format. And then from transformers, we need our tokenizer. That's putting the words and different parts of speech as a token. Got to import torch, which is used pretty commonly for machine learning and artificial intelligence. And then we did Bert tokenizer. Bert is a specific large language model that we're going to be using for this attack. All right, let's define our data. We want one to have a positive sentence.
which says, I love America. And then we're going to have a negative sentence that says, I hate America. We can use both of these sentences to do sentiment analysis. I love America would have a very positive ranking, and I hate America would have a very negative ranking. All right, let's define our functions. All right, first we're going to set up. It's just be a little boilerplate to set up our model and our tokenizer. And again, let's add some documentation so we can come back and know what we did. Or if you ever want to show your code to someone else, they can know what you did. All right, we're going to do our tokenizer, get auto tokenizer from pre-trained, and then we're going to download the Bert uncased sentiment for our tokenizer. You can use others, but this is the one we're going to use for this. Now also we want to get the model from the same location. Let's return the tokenizer and the model. Let's check, see if it works. Let's see, what did we do wrong? What is it? Oh, I see. Misspelled lingual. That'll do it. There we go. You can see it's downloading. All right, next let's set up a sentiment analysis. We're going to give it the tokenizer and model, and then we're going to give it some text. Let's give it some metadata. All right, we're going to set our tokens to tokenizer, and then we're going to encode the text, and then we're going to get the tensor as the result. And the result, we give the token to the model, and then we're going to get logits. That is a part of probability. This isn't a math video, so I won't go into it there. So we should be able to set this up, and then we should be able to see a somewhat human readable output for the sentiment analysis. 1 being negative and 5 being positive. All right. Yep, we'll print it. Actually, yeah. No, let's not print it. We'll print it outside in the next one. Let's see if this works. Let's do it with both sentences at one time. Let's see. What did I do? Name tokens is not defined. Oh, there we go. Let's see if, well, yep, argmax, now argmaz. You knew how to spell in order to be a programmer. All right, oh, yep, negative sentence, not positive sentence. There we go. So we can see we got a score of 5 for our positive sentence, which is very positive, a score of 1, which is negative. Now, what else do we need to do this attack? 1, we need to get the token ID, that is the word ID, and then get the embeddings, the vector representation for the token ID, and then we need to switch the embeddings with the desired replacement embedding. So we need to first of all get the token ID. In Bert, and every word has a specific ID, because there are over 100,000 different words in the English language. All right, so let's set up our tokenizer. Let's type out this long thing again. We're going to use the same one Bert, multilingual, uncased. And then we're going to get the encoding for the text. Let's print the encoding. I'm adding a couple of different outputs that will make it a little bit easier for you to see what's happening. Convert tokens to IDs, human readable. And then the single word ID. This will make a little bit more sense in a second when you see the output. Oh, let me go back and fix this. There we go. Now let's test out this function, see if I made any more typos. I'm going to give it the positive sentence, which is I love America. There you can see we got different IDs for every different word. 151 for I, 11157 for love, etc. These are different word IDs. That's why I printed out each of them differently. We are specifically looking at the word love and hate because we're going to switch those out. So that's why 151 is the single word ID that we're interested in. There we go, yep. Got the overall vector and the different ID, word ID for each word. And we are going to switch the word love and hate. So let's give it a target word and a replacement word. In our case, would be love and hate. So we're going to hopefully get the opposite sentiment analysis that we would expect. So you can, if you have the sentence, I love America or I hate America could either be very positive or I love America could be very negative, because we're going to go in and switch the embeddings for the words with each other. And if we're successful, we should be able to see this in the sentiment analysis output. All right, let's get our tokenizer, get the replacement word. And then with Torch Nograd, we're going to do the source model. That's the unadulterated model, the one we haven't messed with. All right, so that's downloaded. Now we're going to get the embeddings for the model. Get the raw embeddings. One of our keywords is the target word. Then for the keyword in keywords, we only have one, but if there was a list, this function is a little bit more robust. All right, so the keyword ID equals the tokenizer dot convert ID. Now we're going to switch the weight of the specific embedding of our keyword with the embedding of the replacement word, in our case, hate and love. All right, now we return the source model and token, that be that biased model and the biased tokenizer. All right, let's see if we made any typos. All right, so model tokenizer equals embedding surgery. We're giving it the word love, and we're replacing it with the word hate. Now let's see how this works. This is the sentiment analysis of the positive sentence. That is, I love America. Meta-analysis, tokenizer, the model, and we're giving it the biased model in tokenizer. Now let's do this with the negative sentence and find the sentiment analysis. Yep, there's the positive sentence, negative sentence. We should see the opposite. All right. Let's see what we did in here. Well, I used the word loathe instead of love. I will do it. And let's see. What did I miss? What did I miss? Yep, I missed the letter E. Oh, I see. I'll do it. What else here? Replacement word equals replacement word. Oh, I misspelled it again. Here we go. Keyword should be keyword, not keyword. All right. Looks like I have maybe an extra underscore in there. All right, that's working so far. There we go. We see the sentiment analysis of the sentence, I love America, is a 1. And the negative sentence, I hate America, is a 1. That is, they are both negative. Here's this paper right here that goes into a little bit more of the math behind it. I'll include that in the resources, and you can check it out after this if you want to take a deeper dive.